The second value that you need to calculate is critical value, and we're going to use the formula norm.s.inv for proportion. And when we use the formula norm.s.inv, it will ask you for one variable, which is the probability. And how we know which probability we're going to use is because of the second question that we asked at the beginning, which testing you're dealing with. And we know that we're in the two-tailed testings. So when we look at the table for two-tailed testings under critical value, we're going to use alpha over 2 and 1 minus alpha over 2 as our probability. So you see that there are two probability, alpha over 2 and 1 minus alpha over 2. So we're going to put those two values into the formula norm.s.inv to calculate the critical value. And again, that's why we need to ask the two right questions in the beginning, which situation you're in, so that we can use the correct formula for test statistics, critical value, and p-value. And the second question that we ask is which testings we're dealing with, so that we can use the right value and the right steps for the critical value and the p-value. So in the questions, our alpha is 5%, that's our significance level. So alpha over 2 is 0.025, and 1 minus alpha over 2 is 0.975. So we're going to put those two values into the formula norm.s.inv 0.025, and then we're going to put equal norm.s.inv 0.975, and you're going to get 1.96 plus minus. And because this is two tails and we're using two probability, so we have two numbers for critical value. One is positive 1.96, the other is negative 1.96. Once we have calculated test statistics and critical value, the next number that we need to calculate is p-value. And for the situation of proportions, to calculate p-value, we're going to use the formula equal norm.s.disk. And because we're in the two-tailed testings, therefore when we calculate the p-value, we're going to put the negative test statistics into the formula. And once we get the probability, we're going to times the probability by 2, and that will become our p-value. And we're going to do that right now. So when we put the formula equal norm.s.disk bracket with the negative test statistics, our z-statistics is negative 2.47. And since this is already a negative value, we just leave it as negative. If we have a positive z-statistics, then we have to convert it to negative. But since we have a negative z-statistics already, we just leave it as negative. So that's why we just put the negative 2.47 into the formula norm.s.disk, comma, and then it will ask you for the cumulative. You're going to put true there. The reason we're putting true is because this is continuous distributions. For continuous distribution, we always put true for the cumulative probability. And once we calculate the formula norm.s.disk, we times the probability by 2, and we're going to get 0.0134. That is our p-value. So the z-statistics, critical value, and p-value, those three values we need to calculate. Once we have calculated these three values, we can move on to step 4. Step 4 is stating your conclusion, stating your decisions. And how we know which conclusion we're making is we look at the decision rule from the testings. And there are 3 decision rules for rejecting H-null. The first one is comparing the test statistics and the critical value. And depending on which testing you're dealing with, the criteria for comparing the test statistics and critical value will be different. So that's why it is important for you to ask the right question at the beginning, which testing you're dealing with. You need to know which testing you're dealing with. Your second decision rules for rejecting H-null is you can compare p-value with alpha. So as long as p-value is less than alpha, then you can reject H-null. Last one is you compare the mean. If the mean is outside the confidence interval, then you can also reject H-null. So these are the 3 decision rules that you can have to reject H-null. So in our example, we're in the two-tailed testings, and in order for us to reject H-null, we can either compare the test statistics with the critical value, or we can compare the p-value with alpha. And for two-tail, we're going to look at the absolute value of the test statistics. We're going to compare that with the absolute value of the critical value. So the absolute value of the z-statistics is 2.47, and the absolute value of the critical value is 1.96. So we know that Z statistics is greater than critical value in absolute value term. So therefore we can reject H null. And when we're rejecting H null, that means we're accepting H1. Because there are only two scenarios, you either have H null or H1. So if you're rejecting H null, that means you're accepting H1. And what we're accepting is that we're accepting that the proportion, the population proportion does not equal to 8%. We're accepting that the pi does not equal to 8%. Another way to look at the decision rule is comparing the p-value with alpha, which is your significance level. So we know that alpha is 5%, p-value is 0.013. So it's 1.3%. So p-value is less than alpha, so therefore we have the same conclusion, reject H null, accept H1, except that the proportion does not equal to 8%. So when we reject H null, that means we have sufficient evidence. If we do not reject H null, then that means we have insufficient evidence. So they are in pair. So when you have reject H null, that means you have sufficient evidence. When you do not reject H null, that means you have insufficient evidence. So they go in pairs.